Hello, and we're going to be working some problems. This is problem 2.8. In section 2.5, um, practice a skill. So in this section, we are learning about identifying lone pairs. And this problem asks to draw in the lone pairs in this molecule. So this is a carbon-oxygen double bond, and it has, this oxygen has two lone pairs. We know that because oxygen has 6 valence electrons, and it is only using 2 of those electrons in its bond with the carbon. Okay. B is giving us this molecule. So we just learned from A that this first oxygen has 2 lone pairs. What about the second one? Oxygen, again, has 6 valence electrons, and it is only using 2 of those electrons to make bonds with its nearest carbon neighbors. So that means it has 2 lone pairs. You can also know that because oxygen in both of these cases has no charge. And an oxygen with no charge and 2 bonds needs 2 lone pairs. Okay, this is now C. There we are. So we have an oxygen with 2 lone with with 2 bonds and with no charge, so it must have 2 lone pairs. And the bottom, another oxygen with 2 bonds and no charge, so it must have 2 lone pairs. Okay, I'm starting to see a pattern here. D. All right. D is now slightly different because one of the oxygens has a negative charge. And an oxygen with a negative charge and 1 bond has 3 lone pairs. And then the oxygen with 2 bonds and no charge has 2 lone pairs. Okay, let's come over here for E. This oxygen has 1 bond and a charge of -1, so it has 3 lone pairs. In F, this oxygen has 2 bonds and 2 lone pairs. In G, this oxygen has 3 bonds and a charge of +1, so it has 1 lone pair. Actually, I'm going to draw on the other side. There we are. Okay, almost through here. In H, this oxygen has a charge of +1, and it has 3 bonds, so it has 1 lone pair. With I, one of the oxygens has a positive charge, one has a negative charge, and one is neutral. So let's start with the neutral one first. The neutral one has 2 bonds and is neutral, so it has 2 lone pairs. The negative one has a negative charge and 1 bond, so it has 3 lone pairs. And the positively charged one has a +1 charge and 3 bonds, so it has 1 lone pair. Great. And to finish up, J. There we are. Okay, the bottom oxygen has 2 bonds and no charge, so it is the owner of 2 lone pairs. And in the top, the oxygen has has a charge of +1 and 3 bonds, so it has 1 lone pair. This has been the Practice the Skill problem 2.8 in section 2.5 of your book.